When you're doing your data sourcing and you're making data, sometimes you can't get what you want through the easy ways and you got to take the hard way. And you can do what I'm calling laboratory experiments. Now, of course, when I mention laboratory experiments, people start to think of stuff like, Dr. Frankenstein in his lab, but lab experiments are less like this. And in fact, they're a little more like this. Nearly every experiment I have done in my career has been a paper and pencil one with people in a well-lighted room, and it's not been the threatening kind. Now, the reason you do a lab experiment is because you want to determine cause and effect. And this is the single most theoretically viable way of getting that information. Now, what makes an experiment is the fact that researchers play active roles in experiments with manipulations. Now, people get a little freaked out when they hear manipulations, think that you're coercing people and messing with their mind. All that means is you are manipulating the situation. You're causing something to be different for one group of people or one situation than another. It's a benign thing, but it allows you to see how people react to those different variations. Now, you're going to want to do an experiment. You're going to want to have focused research. It's usually done to test one thing or one variation at a time. And it's usually hypothesis driven. Usually you don't do an experiment until you've done enough background research to say, I expect people to react this way to this situation and this way to the other. A key component of all of this is that experiments almost always have random assignments. So regardless of how you got your sample, when they're in your study, you randomly assign them to one condition or another. And what that does is it balances out the pre-existing differences between groups. And that's a great way of taking care of confounds and artifacts, the things that are unintentionally associated with differences between groups that provide alternate explanations for your data. If you've done good random assignment and you have a large enough people, then those confounds and artifacts are basically minimized. Now, some places where you're likely to see laboratory experiments in this version are, for instance, eye tracking and web design. That's where you have to bring people in front of a computer and you stick a thing there that sees where they're looking. That's how we know, for instance, that people don't really look at ads on the side of web pages. Another very common place is research in medicine and education, and in my field, psychology. And in all of these, what you find is that experimental research is considered the gold standard for reliable, valid information about cause and effect. On the other hand, while it's a wonderful thing to have, it does come at a cost. Here's how that works. Number one, experimentation requires extensive specialized training. It's not a simple thing to pick up. Two, experiments are often very time consuming and labor intensive. I've known some that take hours per person. And number three, experiments can be very expensive. So what that all means is you want to make sure that you've done enough background research and you need to have a situation where it's sufficiently important to get really reliable cause and effect information to justify these costs for experimentation. In sum, laboratory experimentation is generally considered the best method for causality or assessing causality. That's because it allows you to control for confounds through randomization. On the other hand, it can be difficult to do, so be careful and thoughtful when considering whether you need to do an experiment and how to actually go about doing it. There's one final procedure I want to talk about in terms of data sourcing and making new data. It's a form of experimentation. It's simply called A/B testing, and it's extremely common in the web world. So for instance, I just barely grabbed a screenshot of Amazon.com's homepage, and you've got these various elements on the homepage. And I just noticed, by the way, when I did this, that this woman is actually a animated GIF. So she moves around. That was kind of weird. Never seen that before. But the thing about this is this entire layout, how things are organized and how they're on there will have been determined by variations on A/B testing by Amazon. Here's how it works. For your web page, you pick one element like what's the headline or what are the colors or what's the organization or how do you word something. And you create multiple versions, maybe just two, version A and version B, which is why you called A/B testing. And then when people visit your web page, you randomly assign those visitors to one version or another. You have software that does that for you automatically. And then you compare the response rates on some response. I'll show you those in a second. And then once you have enough data, you implement the best version. You sort of set that one solid, and then you go on to something else. Now, in terms of response rates, there's a lot of different outcomes you can look at. You can look at how long a person's on a page. You can actually do mouse tracking if you want to. You can look at click-throughs. You can also look at shopping cart value or abandonment. A lot of possible outcomes. All of these contribute through A/B testing to the general concept of website optimization to make your website as effective as it can possibly be. Now, the idea also is that this is something you're going to do a lot. You can perform A/B tests continually. In fact, I've seen one person say that what A/B testing really stands for is always be testing. Kind of cute, but it does give you the idea that improvement is a constant process. Now, if you want some software to do A/B testing, two of the most common choices are Optimizely and VWO, which stands for Visual Web Optimizer. Now, many others are available, but these are especially common. And when you get the data, you're going to use statistical hypothesis testing to compare the differences, or really, the software does it for you automatically, but you may want to adjust the parameters because most software packages cut off testing a little too soon and the information is not quite as reliable as it should be. But in sum, here's what we can say about A/B testing. It's a version of website experimentation. It's done online, which makes it really easy to get a lot of data very quickly. It allows you to optimize the design of your website for whatever outcome is important to you. And it can be done as a series of continual assessments, testing, and development to make sure that you're accomplishing what you want to as effectively as possible for as many people as possible. The next logical step in data sourcing and making data is surveys. Now, think of this. If you want to know something, just ask. That's the easy way. And you want to do a survey under certain situations. The real question is, do you know your topic and your audience well enough to anticipate their answers, to know what the range of their answers and the dimensions and the categories that are going to be important? If you do, then a survey might be a good approach. Now, just as there were a few dimensions for interviews, there's a few dimensions for surveys. You can do what's called a closed-ended survey. That's also called a forced choice. It's where you give people just particular options like a multiple choice. You can have an open-ended survey where you have the same questions for everybody, but you allow them to write in a free-form response. You can do surveys in person, and you can also do them online or over the mail or phone or however. And now it's very common to use software when doing surveys. Some really common applications for online surveys are SurveyMonkey and Qualtrics, or at the very simple end, there's Google Forms, and at the simple and pretty end, there's Typeform. There's a lot more choices, but these are some of the major players in how you can get data from online participants in survey format. Now, the nice thing about surveys is, they're really easy to do. They're very easy to set up, and they're really easy to send out to large groups of people. You can get tons of data really fast. On the other hand, the same way that they're easy to do, they're also really easy to do badly. The problem is that the questions you ask, they can be ambiguous, they can be double-barreled, they can be loaded, and the response scales can be confusing. So if you say, I never think this particular way, and a person puts strongly disagree, they may not know exactly what you're trying to get at. So you have to take special effort to make sure that the meaning is clear, unambiguous, and that the rating scale, the way that people respond, is very clear and they know where their answer falls. Which gets us into one of the things about people behaving badly, and that is beware the push-pull. Now, especially during election time, like we're in right now, a push-pull is something that sounds like a survey, but really what it is a very biased attempt to get data, just fodder for social media campaigns, or I'm going to make a chart that says that 98% of people agree with me. A push-pull is one that's so biased, there's really only one way to answer to the questions. This is considered extremely irresponsible and unethical from a research point of view. Just hang up on them. Now, aside from that egregious violation of research ethics, you do need to do other things like watch out for bias in the question wording, in the response options, and also in the sample selection, because any one of those can push your responses off one way or another without you really being aware that it's happening. So in sum, let's say this about surveys. You can get lots of data quickly. On the other hand, it requires familiarity with the possible answers in your audience, so you know sort of what to expect. And no matter what you do, you need to watch for bias to make sure that your answers are going to be representative of the group that you're really concerned about understanding. The very last thing I want to talk about in terms of data sourcing is to talk about the next steps. And probably the most important thing is, don't just sit there. I want you to go and see what you already have. Try to explore some open data sources. And if it helps, check with a few data vendors. And if those don't give you what you need to do your project, then consider making new data. Again, the idea here is get what you need and get going. Thanks for joining me, and good luck on your own projects.